Welcome to the first incarnation of the confusion tracker. It estimates the area of confusion under observation. The experiment showed that it is effective, performant, and easy to use. Confusion is a part of the learning process. Prolonged periods of confusion can have a permanent detrimental effect. Confusion is most prevalent during complex learning activities. For example, tasks that require a student to draw inferences, answer causal questions, present coherent explanations, and demonstrate a transfer of knowledge. In a traditional classroom setting, teachers can detect confusion with ease. Even though online education environments provide students with some autonomy and flexibility, due to its scale, it is difficult for teachers to support students in a nuanced and personalized way. If we could build a confusion tracker using an existing webcam and internet browser only, which would require no software installation or configuration, then it would be inobtrusive, inexpensive, and scalable for use in larger experiments. Human emotions are observable as the result of the interactions between our cognitive and affective functions. And we also know that behavioral indicators are far more predictive of learning than self-reports. 11 current technology options were reviewed. And we determined that facial emotion recognition with gaze estimation met the ideal solution requirements the best. 3 pertinent objectives were pursued. We wanted to identify that moment the confusion sets in, and then determine what area under observation was confusing. Finally, we wanted to make sure that personal privacy is maintained. Well, how did we fare? 35% of respondents exited the system after the personal privacy briefing. This was much higher than anticipated. Remember, respondents were not given the option to skip the briefing, so at this stage it is unclear if they were scared away or just bored to death. The artworks did confuse respondents. Only 52% of attempts were successful at placing the artwork into their original intended orientation. Respondents rated our area of confusion estimator 3.6 out of 5, with the estimator having an average Euclidean distance error of 170 pixels. Now remember that ballerina on an ocean liner? Here is the mean coordinate of the spot people said was most confusing about the artwork. And here is the spot estimated using their facial features. At the end of it, what can we conclude? This incarnation of the area of confusion estimator is far too crude to lead to any formal conclusions, but the estimator did outperform randomly generated estimates by some margin. Several participants noted that it is not clear, even to them, what they found most confusing about the orientation of the artwork. Almost certainly it is usually a collection of things, rather than a single point. Confusion is an elusive concept. There are many opportunities for improvement in the system, and we look to pursue them in the future. If you have time, visit us at confusion-tracker.com.